How's it doing, everyone? Good? Awesome. So, welcome back. And before we actually start, we have few announcements. First is how many people here are using CSFMX? So they add two additional RAM to Mac 3 and Mac 4, I believe. And also one thing is don't power off their machines because they need to be online to get updates, okay? So when you're trying to terminate your session, just log off the computer from your, log out from your account, okay? Don't power off the machine, okay? Now, another thing is, so I invited Professor Samuel King to be one of our guest speaker, maybe in late April or early next month. We haven't decided the details, but yeah, you are joining us. And so Professor Samuel King is the professor who actually taught the old version of the IELTS programming under the title of ECS 189E. Okay. And now, yeah, let's get started. So today we're gonna talk about like Swift type systems, which is quite intense, I would say. Lots of topic to cover. But before that, actually, we're gonna talk a little bit about computed variable and the order of view modifier. So we already know some view modifier before. Like, for example, like .frame is a view modifier to specify the frame of your views, right? And also you can apply like foreground color and like paddings to your view. They are all view modifiers, okay? But there's one important thing is the order of how you apply view modifiers actually matters a lot. And we're gonna get to that, okay? First, let's take a look at a computed variable. Okay, I have the Xcode playground here. Is that big enough for you guys to see? Okay, good. So, there's one like classic computed variable in the Swift UI world, which is this thing. You guys have seen this a lot of times, I believe, which is the body variable in like literally every Swift UI, every Swift UI view, okay? And this is a computed variable, and I did indeed briefly talk about that before. So it is a variable. It declares like a variable by using a var, right? And this is a type of this variable. And when we get the value from this variable, we actually run the functions inside this block to get some to do some calculation and return a view. Okay. Now, let me show you actually how we actually can use the computed variable in the Swift. First, let me create two dummy value. Maybe I can go with my name, and maybe age, which of course it's first is the name is a string type. Okay, the age is integer. Okay, the compiler gives the integer. And now, for example, you guys can already see there's a greeting variable created by default by the templates. Maybe I want to create a like customized greeting from here. So I can do a computed variable, let's say greet. And one thing to remember is when we define a computed variable, we have to specify the type. The compiler cannot do the type inference for us. We have to specify the type. So in this case, I want the greet to be a string. Now, to do a computed variable, we have to follow a curly brackets after the variable, which is a function we're gonna call every time we use this value. Okay. In this case, I want to return a string with my name. Let's say hello, and with my name. Okay. So when you actually get the value, let's say print greet. Let's run this. Essentially, it go inside this code block and run the code inside it and return the string. okay? And by doing that with the plus sign, we essentially just concatenate two strings together, okay? And the one thing we briefly talked about before is the return keyword here. In some case, we can just get rid of this return keyword. The reason is, actually the policy or the rule is, when the functions explicitly actually return something, but you only have one line code, you can just get rid of the return. For example, like this. And it's exactly the same as before. Now, there's another thing is, we can use another way to concatenate two string or like two different thing, is using string interpolation. So let me show you actually how to do that. I can do some syntax like this, okay? With a backslash and parentheses. Inside parentheses, we can put the variable we want to use. And in this case, by doing like that, Swift, during the compilation, it will replace the variable with the string representation of this value. In this case, it just replaces my name inside this expression. Okay, and if you run this, again, it's exactly the same as before. Okay, that's how we do string interpolation. If you guys want to look it up, it's called string interpolation, I believe. Okay, now, we can also even try to like use the computed variable inside another computed variable. For example, in this case, I want grade with, for example, grade with age, again, it return a string. Okay, now I can say maybe, so start with our grade and say age. Age. Here we go. Now we can print this value. You can see that's how we use computed variable. But there's a important difference between the computed variable and normal variable. That is computed variable can only to get value from that. You cannot set any value to a computed variable because it's computed, right? So, for example, I want to do something like, maybe I want to assign a new string to the grade computed variable. Let's say new string. And you can see the compiler actually gives some warning about that. It says grade is a get-only property, okay? So all computed variable is get-only. You cannot set any value to that. Okay. Any question so far? Okay, awesome. Now, let's see. That's about the computed variable. Next thing is the order of view modifier. Now let's go back to our Xcode project. Let's take a look at this thing we finished last time. Okay. Let's first create a new preview. I can just copy paste this one and give another name, maybe view modifier. Modifier preview. Okay, I can get rid of this thing. Maybe just color. Okay. I believe I mentioned it during the first lecture that this thing, this code block, is a block which our Xcode actually picked up and generated the preview for us. Okay, so if you want like one more preview, you just you can just copy paste. So every struct that conforms or behaves like a preview provider is a preview, and Xcode can see that and generate the preview for us. And in this case, in this preview, I just give it a color. Again, I also mentioned like everything in Swift UI is view. Also, this is also the same case for the color. So color is also a view and can be used as a view. Now, first let me try to apply a frame view modifier on that. I can maybe say I'll go with a rectangle like this. Okay. Now let's also apply a border. on that. Maybe I'm gonna go with black. Maybe 2. Is that visible? Okay. Now let's show you the order of the view modifier. So one view modifier we used before is padding. Okay. Now give a padding, you can see essentially it runs in order. First, it runs this view modifier, and then it gives a padding, and then it gives a border. And view modifier actually is a function call. And let's check out the document. Let's see. Maybe for example like frame. Okay, so here's the documentation for the frame. So the frame essentially is a function. It takes a view and returns a view. This is the return type of this function. It returns a view. So essentially, when you apply a view modifier, it takes the view before that view modifier. Okay, then do some modification and return a new view. So in this case, we can see first it takes the red color, right, and apply a frame to make it a rectangle and return that. Then again, we apply a padding around this, the rectangle, red rectangle, okay? Then it applies a border. In this case, we can do some trick, like maybe in this, like this time we can apply a background. Maybe I'm gonna go with blue. You can see the blue fill out the padding space. Now I can do another padding, and this time I can go with green. You can see how the view modifier actually operates on view. Essentially return different views after each operation. Okay. So in this case, if I swap these two things, and I go with blue first, and I can go with the green first and then blue, you can see the result gonna be different. Okay. So view modifier, the order of view modifier is really important in Swift UI. Okay. Now let's comment this out. Okay. Now let's get into the Swift type systems. Okay. So there's several important type systems in Swift. First is struct, then is class, then is functions. So functions in Swift can be used as variables because they do have type for each functions. Okay. Then is generic types. We also got enum and protocol, but we're gonna leave enum and protocol like to maybe next lecture or next week. So today we're gonna focus on the top 4. Okay. Now let's see struct and class. So first of all, there is some similarity between these two things. They have almost similar or almost the same syntax. And like just check out the declaration way, the way of declaration. You can see the only difference between these two is the keyword. So when you declare struct, you go with struct, right? When you declare class, you go with struct. You go with the class. That's a keyword. Okay. Followed by keyword is the name of your struct or class. Okay. Now, another similarity is for both struct and class, they can have stored variables. So by stored variables, it means essentially like, for example, in this case, the greeting is a stored variable. Okay. And it can also contain computed variable. Computed variable is what I just mentioned before. Okay. And then it can also contain constant lets, which is essentially, again, a variable but declared with a let, and it's a constant. So it's not essentially a variable, it's a constant. And also they can have functions inside both struct and class. But the difference is they have a little bit of difference in the syntax, but we're gonna see that later, okay? So when we just use the properties inside the class or struct, the syntax is exactly the same, okay? But when we actually want to change the property inside the class, you're gonna see the difference, okay? Now, they also can have initializer, or say they must have initializer, right? And you can define your own initializer. Sometimes you may call that as constructor in different languages, like in C++, right? We call constructor. They're exactly the same, okay? So by defining a initializer, we go with a keyword called init, okay? That's how you actually create an initializer for both struct or class. They got the same syntax, okay? Another similarity between these two things is both can conform to protocols and both can be extended. So extension is interesting in Swift, and we're gonna go get to the detail later. But the syntax is just looked like this. You go with extension, which is again a keyword, and you want to extend on my struct, which is what we just declared here, right? You can add additional feature or additional variable, additional functions onto the old struct, okay? We're gonna get to the detail later. Now let's talk about difference. This is really important in Swift. Struct is passed or assigned by copied value, and we usually call the struct as value type. So what do I mean by passed or assigned? So passed means when you actually pass the struct around like different functions, right? You get passed. Or assigned means you just assign a struct to different variables, right? And when that happens, when that kind of operation happens, it gets copied. So take a look at the example below here. So in this case, I instantiate a new struct, right, called my struct, and assign that to a variable named as struct A, okay? And again, I assign the struct A to another variable named as struct B. But they got copied, okay? So there are two different variables, two different instances in this case. So when you actually modify any properties inside struct A, it won't get reflected upon struct B. So there are two different things, okay? But the class is a different story, okay? When the class is passed or assigned, it's got assigned or passed by reference, or you may say pointer. So you don't really see any reference or pointer, at least in this class. But like conceptually, you can think of it's kind of like passed by reference or pointer, okay? And we usually call this thing as reference type, okay? Now let's again take a look at the example here. So again, right, I assign the class A to class B, and they're exactly the same object. They point to the same object in the memory, okay? There's another optional material for this week is copy on write policy. So why that kind of policy exists? So as I mentioned before, the struct is assigned or passed by copies. In that sense, there are going to be lots of copies in Swift code, right? And it creates an inefficiency, right? Because since just got copied again, right? So Swift has the policy which named as copy on write to trying to minimize that cost. So when you actually write some code write some code to assign different value or pass that value around into different functions, it won't get copied immediately. You just kind of delay that process, okay? When you actually change any properties inside that struct, then it get copied. So usually you may just pass things around and use some value. You don't really change that thing. It's okay. It won't actually have too much overhead because it's also kind of like copied by pointer. But when you actually modify something, it get copied. Okay.
Like lazy evaluation?
Well, yeah, it's kind of yeah. So when you change something, now it get copied. Yeah, if you don't change anything, essentially just, again, like some kind of pass by reference or points by pointer. Now, another difference is struct can have inheritance. Struct doesn't have inheritance, but class have. But in Swift world, the class can have, but can only have one inheritance. You cannot get multiple inheritance in Swift. So you might wonder like how we actually do polymorphism like efficiently or like elegantly. So actually in Swift, we don't really use inheritance a lot. Actually, the protocol can be used to achieve the polymorphism. Okay, and we will get to the protocol later. Now, they all have free initializer. What does it mean by free initializer? So take a look at the example, two examples below. So we just declare two variable, two properties inside struct and class, but we don't actually define any initializer. So the compiler, the Swift compiler, actually gonna generate some free initializer for us. We don't have to explicitly to write the initializer. And the struct have multiple free initializer that can help us to initialize all variables inside the struct. You guys may already see that actually. Let me check the code before. So for example, let's take a look at the group card view here, okay? So we define three properties inside this group card view, but we don't have any initializer. At least we don't have explicitly write any initializer, right? But when you actually declare a group card view here, you can see the compiler or the Xcode actually prompts something. You can see this is the free initializer generated by Swift compiler. So you can initialize different things within the this struct that comes for free. Okay. Now let's take a look at the class. So class also have a free initializer, but it only have one initializer, one free initializer, and it initialize actually no variables. So in this case, this is my class, right? This is a class named as my class, and you already have a variable that's get initialized, okay? Initialized as world, and when you call upon this thing, you have a free initialize, but initialize nothing, okay? So if you don't have the initial value for the greeting, and you run this line with the empty initializer or empty constructor, you may say, actually compiler gonna throw you some errors because you have to initialize the greeting upon the instantiation, okay? That's the difference. And the last and the most important thing actually is struct is immutable. So as long as your struct is instantiated, all the property inside this struct is final. You cannot change anything inside this, okay? The only way you can get around that is you create a new struct with a new value, okay? But that sounds like a big limitation, right? So like lots of time doing programming, you want to modify the structure of your code, like the structure of your object, right? That's actually, Swift provide a handy way to do that. So take a look at this example. You may want to change the greeting variable, right, to something else, and go with the mutating keyword before the function. Again, the struct is immutable. So essentially, behind the scene, the compiler actually generates a new struct with a new value for that greeting variable, okay, and swap the location in the memory. So it do the job for you, okay. But again, the struct is immutable. You cannot change when it gets instantiated, okay. One thing to mention is if you want to change some property inside the struct, you go with the mutating keyword before the function keyword. But if you don't actually need to change anything, the syntax is exactly the same as the class, okay? You just write the function and the name and the parameter and the body, okay? Now, let's talk about functions. So actually, you have seen a lot of function definition so far, I believe. Okay, and that's that's our first time officially to take a look at this. The function starts with a keyword as func, okay, and followed by a name. Then it goes with parentheses, just as like usual language, and it comes with parameters. And you may see the parameters is a little bit like complicated. It's okay. We will get to that. Now let's first take a look at the return type. So when you want to specify or indicate the return type, it goes after a arrow key, a arrow symbol. You can go with dash and arrow, right? And int is the return type for this function. Okay. Then you go with curly brackets to implement your function body. And in this case, the return is our keyword to return something. We already see lots of times, and it's essentially the same as many other languages. And in Swift, we use void as a return type to indicate it returns nothing. But if like you don't really return anything, you can just get rid of that part. You can just say, just end at the parentheses and don't put anything. It means return nothing, okay? But if you want to be explicit, you can just go with the arrow sign and void here, okay? That's how you indicate your function return nothing. Now let's take a look at the parameters, okay? Here, there are actually two names for each parameter. Okay, in this case, we have two parameters. First is this one, and separate by a comma, and next is this one. So we got two parameters here in this function. And followed by a type, you can see both two parameters actually are integer, right? But they have actually two names. So I usually call the A here as, or the B here as external names. So the Apple actually calls them as the label, actually, labeling or label. And they also make sense. So why I usually call that as external names? Because when the external names is used by external resource or say caller of your function. So when you call the function, the syntax is look like this. So the name A is used as a name to the caller. You call the add, you go with A, and you go with B. That's external names, okay? Now, correspondingly, the left-hand side LHS, the RHS is the internal names. So they are used internally in your functions, okay? Now, that's a parameter type, and it's pretty, you have seen that kind of syntax a lot of time so far, okay? And you can also omit external name by using this underscore mark. So sometimes you may just, you don't want the external name. So because if you have a long external name, your caller gonna be like, they have to put lots of typing here, right? Sometimes you just want to save some space or save some typing, you can get rid of the external name by using the underscore. And by using this, when you call this function, you go with add 1 and comma, B and 2, okay? That's how you omit external names. And you can also combine external name and internal name to the same name or to the same label. In this case, I just get rid of the external name. I just go by one name, which is LHS here, okay? And in this case, when I call the function, I use LHS as external name and internal name at the same time, okay? Now, let's think about like why Swift actually want to like have this feature, like why they want to have external name and internal name at the same time. The reason is the Swift team wants to create a natural language flow when you call the functions or when you're programming. So for example, I can change the definition to this. I can say, for the first argument, I get rid of the external name, okay? And for the second argument, for second parameter, I'm gonna go with as its external name. And when I call this function, I say add 1 with 2, right? Or I can go with, maybe I can change the with to 2, right? When I call this function, then it becomes add 1 to 2, right? That's how Swift make the language or make the function call works actually like you just reading some text or reading some English, okay? Now, that's why that's the important thing about like why functions can be used as a regular variable in the Swift because every function has its type. In this case, again, that's our add function we defined before, right? And it has a type. So the type the type annotation or the type when you express the type, you write as like this. So inside this parenthesis, it goes with arguments type. So in this case, I say the add takes 2 arguments, and both arguments are integers, and it returns an int, right? So I write as int and int. It means it takes 2 integers. And after the arrow key or the arrow symbol it's the return type. Again, it's an integer. That's the type of this function. Okay. Every function has a type, and the compiler gonna infer the type during the compilation, and it will assign this type to the function. Now, as I mentioned before, every function in Swift can be used as regular or normal variables. So for example, I can see, well, again, we have the add function, right, just as before. Now we can define a new variable, and we give a type, which is the same type as our add function. And we can assign the add function to our new add, which is the variable we declare, right? Now we can just use the new add variable as a function call. That's how you actually assign the function to a variable and use the variable as the old function, okay? Because they have the same type, and the compiler can do the job for you. Now let's take a look at how we actually pass our function around into different functions. So the add function is again the same as before. Now we have a new function, which is called calculate, okay? And it takes 3 arguments, 3 parameters. First parameter is integer. Second parameter again is an integer. But third one is a function actually. So you name it as op, stands for operation, okay? And the type is take 2 integer and return integer, okay? And inside this function call, we just like use the op variable as a function, right? We call the function upon the op variable, okay? Now let's take a look at how we actually call this function. So we can call calculate with 1 and 2, and again pass into the add function into the calculate function, okay? And we will get 3. That's how you pass function around, okay? Now there are some example of other possible function types. There are lots of different function types in the Swift because, well, you can define whatever function you want, right? But there are some example here. For example, the first case, the function takes the integer as argument and return nothing because we use void, okay? The second case, we take nothing and returns nothing, okay? The third case is we take nothing but return Boolean, okay? You can also get lots of different function type if you want. Now, that's closure. The next topic is closure, and the closure is very, very important concept in Swift. And that's kind of cornerstone of any functional programming language, okay? And today we're gonna give you a little bit like a brief introduction about closure, but we'll get into detail about closure maybe in week 4 or week 3 or next week. But anyway, so when we pass function around, we often inline these functions, and we call this inline function as closure in Swift. Let's take a look at the code and to see what does that mean to like inline these functions. Again, that's a calculate function we defined before. That's exactly the same as before. Now this time, I don't pass a add function inside this calculate function. Instead, I inline this function here. Okay, that's the syntax here. It goes with a curly brackets. Okay, inside this, the a and b is the parameter that function takes, and use the in keyword to separate between the body of your function and the parameter of your function. Okay? Again, I use return to add these two things up. Okay? Again, we got a 3 because it's essentially just the add function, but we simplify lots of things. Okay? We inline the add function into the calculate. Okay? Any questions so far? Anything? Oh, good. Okay. Now, so if you are familiar with other languages, you might also heard of some name like anonymous function, right? Lambda function, right? In other language. But actually there are some difference between anonymous, like normal anonymous function or lambda function. The reason why we call this inline function as closure in Swift because it captures environment. It's kind of take a closure of the entire environment and pass it around. And by meaning capture environment, we're gonna see the concrete example later. Okay, and you can see how powerful it is. Okay. Now let's get to the generic types. So what if when we actually define our function, for example, when we define the add function, right? We don't want just add to integer. We want to add a function can add anything, right? But we don't know the concrete type during the process of writing your code, right? How are we supposed to do that? Again, we use generic types. The syntax is pretty like the other popular language, okay? It goes with angle bracket. And this is the virtual type. So you don't know what kind of type it is, you just give a name, okay? You go with, for example, I go with number, okay? And I replace all the type with this label. Like I go with a number, and returns a number, okay? You can implement your add function in this way. However, the add function actually won't work in this case. There's some limitation or there's some constraint when you actually implement this function, but we're gonna talk about that later, which involves protocols, because you cannot just add two random things together, right? It can be dangerous. So the protocol thing is involved in this case, and we'll get to that. But for conceptually, we want to define a generic functions. You can go with generic type like this, okay? Now there's an example. So this code snippet is exact declaration or definition from the standard library, okay? So this is for array, okay? So array, again, takes a generic type, and the Apple gives the virtual name as element, okay? And then when you define the append function here, you see it takes the argument, the external name got omit, okay? It doesn't have an external name, but it has an internal name, has new element. And the type is the element. The element is just a label. It gets inferred during the compilation, okay? Now there are some additional notes. So you have, you may already seen this in the first lecture, right? So when you declare a array or you do some type inference, type annotation for your compiler, you go with the square bracket, right? And put that int inside this. It means the array takes an integer. And during the compilation, so it's a syntactic sugar. So during the compilation, this is actually gonna swap this thing with this thing. So this thing is actually the real definition or the real type for your array, okay? This is done during the compilation. You can also go with array, angle bracket int, angle bracket, right? During the, when you write your code, it's exactly the same thing, okay? Okay, now, let's get back to our S code to see how we actually can dynamically change things. So for example, in this case, take a look at this preview here. So for example, I want that user to be able to maybe change the color for the label. For now, I have blue and red for the group label color, right? How about like I want to let user to change this? Okay, so first thing we're gonna do is add a button, right? Because if user want to change anything, I have to provide a way to interact with the user interface. So maybe I'm gonna add a button like on the left of this icon, okay? Now, that's a new thing, like how to actually create a button in Swift UI. We go with button. And it takes a string as the label of this button. I can go with change color. Okay, and followed by a function call. And this thing you also again see lots of times, like for example, like edge stack right here and v stack, all those things. It's a closure actually. So it pass into the, for example, here the button. So it pass the closure into the button's initializer and do something later. So in this code block is the function or the action we want to define for the button. So when user click on the button, what kind of action, what kind of behavior we want to achieve. In this case, it can change the color. I want to change the color, right? So I can say if, let's see what name we give it. It's a group label color, okay? So like if group label color, okay, equal to maybe, what's the original color? It's blue, right? If equals to blue, okay. And we're gonna change the group label color to maybe green. Else, we're gonna, well, change it back to blue. Okay, let's try to run this code. You can see the build actually failed. So give the compiler a little bit. Okay, here we go. We can see there's some error here. It says self is immutable. Okay, one important thing is self. What kind of, so what self is, so what is self? Okay, so when you use the group label color, right, it comes from the struct, right? And you may see the similar things in our language, like in C++, you can use this, right, I believe. And in this case, you actually have a self. You use the group label color from this class. You go with self, okay? And the Swift is like, it's smart enough to infer that you're actually using the value, using the variable from the struct itself. So you can just get rid of the self. But I personally do prefer to be explicit, okay? And why the arrow is, so why the arrow said the self is immutable, okay? That's a very important thing. I mentioned lots of times the struct is immutable, okay? Now how we actually solve this problem, because struct is immutable. One thing the Apple provides for us is called, let me show you. You write like this, at state. So this thing is called property wrapper. And we're gonna actually to see the details about this thing later, maybe week 7 or week 8. But essentially it gives some additional feature. And the feature is achieved by compiler during compilation. So in this case, it's kind of similar like the mutating keyword. So it tells compiler when you actually change the variable, do some special things, like create a new group card view, which is a struct, right? Create a new group card view and swap a location to a new one, okay? That's how you change the variable inside a struct. You give it a as state before that variable you want to change, okay? Now let's take a look at this. Okay, let's resume the preview. And one thing to mention is when you have some elements that can be interact, you cannot, give me a second, what's going on? So the preview is static. So if you have any elements can be interacted, you cannot you cannot actually interact with the element right inside the preview. You have to run it first. So there's a play button here. You can run your simulator inside your Xcode. Okay. Now it started. Let's try to change the color here. You can see now it becomes to green because, well, we code specify what kind of behavior it has, right? Now there's another thing about this block, the if else, right? When you write your code, you don't want to, like, sometimes you don't want to so many lines because it adds lots of typing, right? And there's a new thing we can use in Swift. It's called ternary operator. Anyone heard of that before?
Question mark?
Yup, question mark with a colon. Okay, let me first show you the syntax. Okay, so we go with if this thing, this thing equal blue. Let's see. We go with what's that? Green. Sorry. Go with green. Else we go with blue. Let's hype this thing. Let's get the screen a little bit. Here we go. So this is syntax of ternary operator. So how we do that? How we actually understand this syntax? So first, we're gonna run this code, and we first check the Boolean value of this expression. So this time I say if our group label color is equal to a blue one, right? So if it is true, we're gonna go with this one. If it's not true, if it's false, we're gonna go with the next one, okay? And it returns a value. In this case, it either returns the green color or it returns a blue color. And again, you get assigned this color to this variable, which is our group label color. Now you have exactly the same behavior if you want to test it out. Okay, now as you can see, they're exactly the same. Okay, so if sometimes you want to, minimize some code or get some fancy way to do if-else statement, you can do this way. Okay, it's called, I don't know actually how to spell that. Ternary if operator. Yeah, I think so. Yeah. Any question? Anything? Okay. Awesome. Then I think that's all for today. And thank you for being here. All right. See you guys Thursday.